Alright everybody, so we're going to look at numbers that are not in scientific notation and then fix them. So we've got 35.4 times 10 to the power of negative 3. So anyone watching from home, just press pause on the video and try to do this yourself, and then I'll do it with you, okay? So feel free to try it, but the first tip I'm going to give you if you're stuck is that a number in scientific notation number needs to look like this. You've got a digit, then a decimal point after the first non-zero digit, or the first whole number if you like. And then you've got the rest of the digits, whatever they are, times 10 to the power of something. So the key is, like, this can't be 0, by the way, and the decimal point has to be after the first digit. So what I'm trying to say is, this must look like this: 3.54 times 10 to the power of something. I'll put that down there. When we figure it out, it should look like this: 3.54 times 10 to the power of something. And I'm not sure what that something is yet, but that's what we need to figure out. But that's what our answer needs to look like. Now, does that make sense, what we're trying to do here? Alright, so take your time. And then great. So anyone watching from home, just press pause and try it now. I'll do it. So I hope you tried it. I'm going to go over it now. So I want to just forget about this times 10 to the power of negative 3. Just forget about that for the moment. And I'm just going to rewrite 35.4 with a decimal point in front of the 3. I'm going to go 3.54 times something. So everybody tell me, like, 3.54 times what would give me 35.4. In other words, if I was to rewrite 35.4, what could it be? 10. Right. Times 10 basically, right? Or 3.54 times 10 to the power of 1. Same thing. Because look, if you take 10 and you multiply it by 3.54, you get 35.4, right? And so that becomes this. It's just rewritten. It's just rewritten a different way. And then we can bring down this times 10 to the power of negative 3. And now we can combine our 10s. Because we're multiplying by the... So we can multiply by the same base. And then what do we do with the exponents? We add them, right? Add the exponents. Yeah. So if we add them, it's 1 plus negative 3. Add the exponents, 1 plus negative 3, and that gives negative 2. And so that's the answer, right? Now, just for fun, like, there's no harm. Why don't we just go ahead and check this on a calculator, even if you want to? Because, like, what this is 35.4 times 10 to the negative 3, by the way, is 1,000th, which looks like this, 0.001, because it goes tenths, hundredths, thousandths. If you multiply by that, then this decimal point goes 1, 2, 3 spots over, and you get a 0 there. So you get 0.0354. So this number is this. And then if I was to put that in scientific notation, I could go 1, 2 spots and get 3.54 times 10 to the power of 2, and is it positive or negative? Well, it's going to be negative because that's a small number, right? So, like, that's kind of another way of doing it. You could just multiply, figure out that it's that decimal, and then get it back to scientific notation. So you can either go this way, or you can go this way. Or you could even, if you're confused, go, okay, 35.4 times, 10 to the power of negative 3. By the way, this is negative, this is subtract. If you mess them up in your calculator, it won't like it. So this is the negative sign, that's subtract. Anyway, and you get that, and then, okay, that's 0.0354, and then you turn that into scientific notation. So you could get it that way, right? So, but by all means, feel free to do it both ways if it makes more sense.